Good morning, welcome to Lighthearted Academy. Today we're continuing on Trigonometry lesson 42. Last week we have talked about solving trigonometry equations. So this lesson we're moving on from the fundamental identities to the next set of identities, which actually derives from the fundamental identities basically. From the fundamental identities we can derive the sum and difference formula, the half angle formula, the double angle formula, the sum to product formulas and product to sum formulas, and all the other formulas that are very commonly used in trigonometry expressions, simplified expressions, verifying identities and things like that. But we're going to start with the most important one, which is called the sum and difference formula. Okay, and then this is I want to show you the derivation of sum and difference formula, so let's go ahead and start with that. Alright, so suppose we have an angle theta, okay, and let's go ahead and mark theta here, and then we have another angle phi. Alright, so I'm gonna make them just I'm gonna make them definitely different. Okay, so as you can see, this is angle theta and this is angle phi. Alright, and so coming together this is from here to here, this would be theta plus phi. Okay, alright, so we want to find out what is the sum and difference formula. By definition, just by the name, is talking about the sum and difference of two angles. Sum and difference formula gives us the sum and difference of two angles. So let's talk about the sine of sum of two angles. So we're going to find out, when we add two angles, what would happen to the sine of the sum of two angles, theta and phi. Okay, alright, so let's go ahead and do some labeling first. Okay, alright, so this is a I'm going to do some opposite sign. Alright, let me go ahead and label some letters first. Let's label the origin O, and let's label this point A and this point C. Okay, AC, and let's label this point B, and let's label that point P. Okay, but also I'm gonna label a little bit here. Well, let's go ahead and do this first. Okay, so as you can see, triangle AOC has to do with angle theta, right? Triangle AOC has to do with angle theta. So the AC is the opposite side of theta, OC is adjacent side of theta, and AO is the hypotenuse of theta. Now I need to have another segment connected here from OP, from P to A. From P to A. So now you can see this. Actually, I think I made a mistake. Okay, let me go back. Alright, so P is here, that's correct, but my A and my C cannot be here. Okay, I have to change them. I'm going to show you why first, later. Okay, so but I'm going to make a right angle here. There we go. So I hope that looks like a right angle here. So this is going to be a right angle. Alright, I'm going to make A like that. Okay, and then make this a right angle. This is going to be right angle, and C right like that. And I'm going to make another segment here. It's just a different color. A perpendicular segment from A to PB. Alright, let's call that D. Okay, so this is a right angle as well. Okay, alright. So this way, AP is the opposite side of phi, AO is adjacent side of P, and OP is the hypotenuse of phi. Okay, and then AO is the hypotenuse of theta, AC is the opposite side of theta, and OC is the adjacent side of theta. But PB would be the opposite side of theta plus phi, and OB would be the opposite side of theta plus phi, and OP is the opposite side of the theta plus phi. Okay, so let's go ahead. I think we should be able to go ahead and take a look at what's going on here. Alright, so let's go ahead and derive. So we want to find out what is the sine of theta plus phi equal to. Now look at this diagram. Sine of theta plus phi is the opposite side, which is PB. Okay, it's the longest segment opposite to both angle. Divide by PO, right? Divide by PO. Let's write it O, or write it OP here. Divide by OP is the hypotenuse, which is this is the hypotenuse. Okay. Right. Now let's break it down. PB, which is the distance from P to B, is equal to PD plus BD. Do you see that? But PD, okay, is this segment, and DB is this segment. But these DB and this AC are equivalent because it's a rectangle. Okay, and opposite side rectangles are equivalent, so DB and AC are the same. So I can write this as AC plus PD. Okay, I can separate them into two. Let me go ahead and write this a little better. AC plus PD divided by OP. Okay, so PD and AC, they add them up, they equal to PB. Alright, so and then we can separate. Therefore, we can separate them into two fractions: AC over OP and PD over OP. Alright. Now AC over OP is okay, and PD over OP. Now, AC over OP and PD over OP, they have nothing to, they are not functions, and they are not related to theta or phi. So that won't help us to understand. We want to convert. We want to be able to express this fraction and this fraction in terms of functions of theta and phi, so we can understand them better. Now, there's a little angle here. First of all, I might want to add. There's a little angle right there. What is that angle? Okay, so first of all, let's take a look at this angle theta, right? So angle OAC right here, angle OAC is 90 minus theta. And look at this. This is 90 minus theta, and that's 90 degrees, right? This angle PAO is 90 degrees. So this is 90 minus theta, and that is angle DAC is 90 degree. So this little angle right there is theta. Right here is theta, because this is theta, because this is theta, and the reason is they are interior alternate interior angles. If you remember, when you have two parallel lines, you have a transversal. Those two are alternate interior angles. So this is theta. But you can also see that this angle is 90 minus theta. So this guy has to be theta. Okay, because they add up to 90 degrees. So if this is theta and that's 90 degree minus theta, right? This is 90. So OAD and DAP add up to 90. So this guy is theta. So this has to be 90 minus theta. That means this guy is also theta, because those two angles also add up to 90 degrees, because ADP is 90 degree angle, so that's a triangle. So this angle is equivalent to theta. So PD and PA and AD has a different relationship now, because they are now related to theta. So I don't just have to stick with AC, AO, and OC to deal with theta. I can use PA, PD, and DA to deal with theta. Alright, so let's go ahead and do this. We're gonna multiply them by something. Okay, now I will explain to you why we're gonna multiply them something a little bit later. So the first fraction, we're gonna multiply by OA by OA. Okay, the second fraction PD by OP, we're gonna multiply by PA by PA. So we're not changing how they're written, but we'll just multiply this, and let's see what will happen. Okay, so we multiply this, and let's go ahead rewrite them. Let's write OA over OP, and let's write AC over OA. Okay, and let's go ahead and switch their places. Let's write PA over OP, and let's write PD over PA. Alright, so let's take a look at what is OA over OP now. Okay, OA is this side, which is the adjacent side of phi. OP is the opposite side, hypotenuse of phi. So OA over OP is actually cosine of phi. And AC is this side, okay, over OA, Well, AC over OA is definitely sine of theta, because AC is opposite side of theta, OA is the hypotenuse of theta. What about PA over OP? PA here is the hypotenuse, or it can be the opposite side of theta, phi, and then OP is the hypotenuse of phi. So this is sine phi. Okay, and PD is this side over PA. Now PD and PA are related to theta here. PD is the adjacent side of theta, and PA is the hypotenuse of theta. So this is cosine theta. So let's clean this up a little bit, and then we'll be able to see. So what that gives us is that sine of theta plus phi is equal to sine of the first angle of theta times cosine of the second angle phi plus cosine of the first angle theta times the sine of the second angle phi. So this becomes a very powerful formula for us to use, because this way we can break it down. We can break down this expression very, very simply, and then I have showed you how this is brought about by using this diagram of triangles. Okay, and we can do the same thing for cosine. Okay, so let's go ahead. Let's just see the picture again. We're going to use this picture to go ahead develop the cosine. So, all right. So let me pause here for a moment. If you need to write it down, okay, take some notes. Alright, let me go ahead and erase this part so we can use this diagram. Alright, so now let's go ahead and take a look at the cosine of the sum of two angles. Okay, so let's see if we can go ahead and try to recreate that. Okay, so let's do cosine of sine plus phi. Okay, now cosine of sine plus phi, which is OB, okay, which is OB over OP. Okay, OB is the adjacent side of sine plus phi, OP is the hypotenuse. Now, what does OB equal to? Well, in the bigger scheme, OB is OC minus BC. Do you see? Minus BC. But BC is related to DA. Okay, we're going to use PDA. We're not going to use BC because BC is not related to anything. But DA is related to this angle theta. So we're going to do OC minus DA over OP. Okay, so there's a subtraction sign there. Alright, so it's going to be OC over OP minus DA over OP. Okay. Now we're going to multiply by OA over OA again, and let's see how well that worked out. And this time we're going to multiply the second fraction by PA over PA again. Alright, now because PA is actually the hypotenuse, and then OA is actually also the hypotenuse and the adjacent side. So PA is the hypotenuse for this triangle PDA, but it's also the opposite side of OPA. So those are very interesting ones. So let's go ahead and switch them a little bit. Okay, let's do OC over OA equal to OA over OP minus, let's switch them as well. Let's do DA over PA, and then PA over OP. Okay, now each triangle will be related to theta phi. So OC over OA, that's very simple, that's cosine theta. OA over OP, that's cosine phi. Okay, that's good. Subtract. DA over OP, DA is the opposite, okay, over PA, so that's the opposite over hypotenuse, sine of theta. PA is the opposite of phi over OP, this is the cosine of, sine of phi. So that is the formula for cosine theta. Okay, alright, so now let's go ahead and review what we have just done. Right now we have gotten the sine of the sum and difference theta for sine, okay, which is sine theta cosine phi plus cosine theta sine phi. Okay, and we have cosine of theta plus phi equal to cosine theta times cosine phi minus sine theta sine phi. And how do we get tangent? Well, to get tangent, we simply divide them, okay? So the tangent of theta plus phi will be very simple, which you can just simply divide them. And once we divide them, once we work through, it will become like this. It will become tangent theta plus tangent of phi. So I'm not going to derive this for you right now. You can go ahead and try to work it out on your own to divide it and see, yeah, if you can get this by using the techniques that we have done. So it's going to be tangent theta plus tangent phi over 1 minus tangent theta and phi. Okay. Now, what about the subtraction? We have the sum, right? What about the difference? The difference are actually very much the same, because all we have to do is to change the sign. So for sine, the sign will be changed in the middle. Okay, it will be sine theta cosine phi minus cosine theta sine phi, and cosine theta minus phi will be cosine theta times cosine phi plus cosine theta sine phi. Okay, and for tangent theta minus phi, the sign will be changed as well. So it will be tangent theta minus tangent phi divided by 1 plus tangent theta tangent phi. Okay. Alright, so those are the formulas. Now, sometimes on the formula sheet you will see something like this: sine theta plus minus phi equal to sine theta cosine theta phi plus minus cosine theta sine phi. Okay, so what does this mean is that this is a shorthand of combining two formulas into one, so we don't have to write them twice. It's that sine of theta plus phi follows the top sign, sine of theta minus phi follows the bottom sign. Okay, so top follows bottom, the bottom follows the top. For cosine, you will see something like this: cosine theta plus phi equal to cosine theta cosine phi minus plus sine theta sine phi. Okay, so just make sure that you understand what the notation means. Alright, now how do we use this? Well, one way to use this is to find the exact value of some certain functions that's not otherwise found on the unit circle. For example, let's go ahead and see if we can try to find the exact value of sine of 75 degrees. So yes, you can go and type this into calculator. It will give you a decimal answer. Now, some calculator will actually even give you the exact answer, but let's go ahead and see how we can break it down. Well, sine of 75 degrees is equal to sine of two angles, right? Now I can think of 30 plus 45. Now, of course, there's a lot of compositions of two angles added to 75 degrees, but we want to use the one angles that we know exactly, which is the ones that are on unit circle, like 0, 30, 45, 60, and 90, and their multiples. So we want to use this too. Alright, so let's apply the formula very quickly. Sine 30 plus 45, so this will be equal to sine of the first angle times cosine of the second angle plus cosine of the first angle 30 degrees times sine of the second angle, which is 45 degrees. So basically it's the sine 30 times cosine 40 plus cosine 30 times sine 45. And then we can go ahead and use our unit circle to find the exact answers. So sine of 30 is 1/2, cosine 45 is square root 2 over 2, cosine 30 is square root 3 over 2, right? And then sine 45 degrees square root 2 over 2. So now we can go ahead and just multiply them together. So the square root is 2 over 4 plus square root 6 over 4. So the denominator is the same, so we can go ahead and write them together. Square root 2 over square root 6 over 4. So this is the expression for the exact measurement of sine of 75 degrees. And let's do one more problem just like this. Okay. Let's go ahead and do cosine of 105 degrees. Okay. Now we can do subtraction or addition. Okay. Now cosine 105 degrees, I can do cosine of 60 degrees plus 45 degrees. That's one of the first things I can come up with. So let's go ahead and use the formula. So it's going to be cosine of 60 times cosine 45 minus sine of 60 times sine of 65. So for cosine of sum, the sign is different. Okay, it's actually a minus in the formula. And so cosine of 60 degrees is square root 3 over 2. Cosine of 45 degrees is square root 2 over 2. Minus sine of 60 degrees is 1/2 No, actually, I'm sorry, my bad. Cosine 60 degrees is 1/2. Sine 60 degrees is square root 3 over 2, and sine 45 degrees is square root 2 over 2. Alright, so let's multiply them together. Is square root 2 minus here square root 3 times square root 2 is square root 6 divided by 4. So this is square root 2 minus square root 6 over 4. Okay. Alright, so there are many other ways that we can go ahead and work on this. I think we'll have to go ahead and save that for the next lessons. So, thank you for joining us today. Please leave any questions and comments in the question and comment section. Please subscribe and share this with your friends. And we'll continue to work on our trigonometry lessons. And hope to see you again join us in the future. Thank you.